Imagine a world ruled by giants, creatures so vast they reshape the very landscape beneath their thunderous feet. For 165 million years, these titans dominated Earth, an undisputed reign unlike any other in our planet's deep history. This is the incredible saga of the dinosaurs, a chronicle spanning epochs, from their humble beginnings to their ascent as Earth's most formidable inhabitants, and ultimately their dramatic, almost unimaginable end. Our journey begins not with a roar, but with a whisper, in an era of profound geological and biological upheaval, long before the familiar continents we know today had taken shape. We must cast our minds back over 250 million years to a time of cataclysm. The late Permian period witnessed the most severe extinction event in Earth's history, a catastrophe so profound that it wiped out an estimated 90% of all marine species and 70% of terrestrial vertebrate families. This was not a quick demise. It unfolded over hundreds of thousands of years, driven by massive volcanic eruptions in what is now Siberia, spewing forth unimaginable quantities of greenhouse gases and toxic aerosols. The world became a hothouse, oceans acidified, and life teetered on the brink. This cataclysm, known as the Permian-Triassic extinction, left the planet barren, its ecosystems shattered and vast swaths of land empty of complex life. The few survivors faced an arduous path to recovery, navigating a world radically transformed. This ecological void, however, was also an unparalleled opportunity. It was into this crucible of desolation and rebirth that the ancestors of the dinosaurs emerged. The early Triassic, spanning from roughly 252 to 247 million years ago, was a period of slow, tentative recovery. The dominant terrestrial fauna were initially synapsids, the mammal-like reptiles that had survived the Permian Holocaust, along with early archosaurs, a group that would eventually split into the crocodile lineage and the bird dinosaur lineage. These early archosaurs were often small, agile, and opportunistic, scrambling for resources in a planet still reeling from environmental trauma. They were not yet the behemoths of popular imagination, but rather modest creatures, often no larger than a dog, living in the shadow of other emerging reptile groups. For many millions of years, the dinosaur lineage remained relatively obscure. The Middle Triassic, from 247 to 237 million years ago, saw a diversification of reptilian life. Crucially, the dominant predators of this period were not dinosaurs, but large, crocodile-line archosaurs, known as pseudosuchians. Creatures like Postosuchus, a formidable bipedal predator over 4 meters long, ruled the land. These were powerful, heavily armored beasts, perfectly adapted to the post-extinction world, and they occupied the apex predator niches. Dinosaurs, meanwhile, were still in their infancy, literally, as a group. Their earliest known representatives, appearing around 235 to 230 million years ago, such as Herosaurus from Argentina or Aeoraptor, were relatively small bipedal carnivores. They were fast and efficient, but not yet kings. These early dinosaurs possessed several key evolutionary innovations that would eventually prove decisive. Their upright gait, with legs positioned directly beneath the body, unlike the sprawling posture of most other reptiles, allowed for greater stamina and agility. This posture, combined with an advanced respiratory system, gave them a distinct advantage in a rapidly changing world. They could run further, breathe more efficiently, and likely tolerate higher activity levels than their competitors. These adaptations, honed over millions of years of competition and environmental pressure, were the silent weapons that would eventually propel them to global dominance. The supercontinent Pangaea, which encompassed nearly all of Earth's landmass, played a pivotal role in the early distribution and subsequent diversification of dinosaurs. Without significant oceanic barriers, terrestrial species could spread relatively freely across vast distances. This allowed early dinosaur groups to colonize diverse environments, from arid interiors to coastal plains, laying the groundwork for the astonishing variety that would later emerge. By the late Triassic, approximately 237 to 201 million years ago, the first true dinosaur radiation was underway. While still overshadowed by pseudosuchians in some regions, dinosaurs were beginning to carve out their own ecological niches. Sauropodomorphs, the ancestors of the long-necked giants, began to appear, with species like Plateosaurus from Europe representing some of the earliest large herbivores, reaching lengths of up to 10 meters. Sleepless, a slender, agile carnivore, hunted in packs in what is now North America, exemplifying the increasing success of smaller theropods. These dinosaurs, though not yet at the peak of their evolutionary prowess, were proving themselves adaptable and resilient. Then, around 201 million years ago, another major extinction event struck, the Triassic-Jurassic extinction. While not as devastating as its Permian predecessor, this event significantly impacted terrestrial ecosystems, wiping out many groups of large pseudosuchians and other reptilian competitors. The causes are still debated, but massive volcanic activity associated with the breakup of Pangaea, releasing vast amounts of CO2 and sulfur aerosols, is a leading hypothesis. This cataclysm effectively cleared the stage, creating a vacuum in the ecosystem. With their primary rivals gone, the dinosaurs, which had already diversified and possessed superior physiological adaptations, were perfectly positioned to inherit the Earth. They had not just survived, they had endured and were ready to thrive. The early Jurassic period, from 201 to 174 million years ago, marks the true beginning of the age of dinosaurs. With the competition largely eliminated, dinosaurs exploded in diversity and size. New species rapidly filled the vacated ecological niches. The modest Plateosaurus evolved into the colossal, long-necked sauropods, which would become the largest land animals ever to walk the Earth. Agile, predatory theropods grew larger and more specialized, laying the groundwork for future giants like Allosaurus and Tyrannosaurus. Armored dinosaurs and ornithopods also began their ascent, evolving complex defensive strategies and feeding mechanisms. This was the moment of their triumph, the moment the world truly became theirs. From inconspicuous beginnings in a broken world, through millions of years of intense competition and successive global catastrophes, dinosaurs had proven themselves to be the ultimate survivors. They had weathered the storms, adapted to the changing landscapes, and seized every opportunity to flourish. Their incredible journey was only just beginning, a spectacular rise that would define an entire epoch, culminating in a reign that seemed, for a time, utterly unshakable. The vacuum left by the Triassic-Jurassic extinction was filled with astonishing speed, ushering in an era of unprecedented evolutionary innovation and gargantuan scale. What forces propelled the dinosaurs from survivors to undisputed overlords of Earth in a mere blink of geological time? The answer lies in a confluence of environmental opportunity and inherent biological advantage. As the supercontinent Pangaea continued its slow, inexorable rifting, shaping new coastlines and landmasses, the global climate stabilized into a warmer, more humid state. Lush, verdant forests, dominated by conifers, cycads, and ferns, carpeted vast swaths of the planet, providing an almost limitless buffet for burgeoning herbivore populations. This was the vibrant, green canvas upon which the true age of dinosaurs would be painted. A world ripe for the taking. The early Jurassic, from 201 to 174 million years ago, witnessed a dramatic shift in terrestrial ecosystems. The first to truly seize this opportunity were the sauropodomorphs, the lineage destined to produce the planet's largest land animals. Building on the foundations laid by their Triassic ancestors, these long-necked herbivores underwent an explosive diversification. Within tens of millions of years, species like Gonxianosaurus and Vulcanodon emerged, creatures already pushing the boundaries of size, often exceeding 10 to 15 meters in length. Their anatomical adaptations were remarkable. Lightweight, hollow bones, often filled with extensive air sacs connected to their highly efficient respiratory system, reduced the burden of their immense bulk. This advanced respiratory system, akin to that of modern birds, allowed for a continuous, unidirectional flow of oxygen-rich air, enabling them to sustain high metabolic rates essential for gigantism. Their incredibly long necks, supported by powerful ligaments and muscle, acted as sophisticated, wide-reaching foraging devices, enabling them to browse from vast areas without moving their massive bodies. This energy-efficient feeding strategy was key to their success, exploiting the abundant, high-fiber plant matter that defined the Jurassic landscape in the shadows, and often in pursuit, the predator. Rhizopods also underwent a significant transformation. From the agile but relatively small Coelophysis, new, larger, and more specialized carnivores began to dominate. Early Jurassic theropods like Dilophosaurus, with its distinctive double crests, or Cryolophosaurus from ancient Antarctica, showcased a growing range of predatory strategies. While not yet the colossal titans of later epochs, these predators were formidable, often exceeding 6 meters in length, equipped with sharp, serrated teeth and powerful claws. Their bipedal stance provided speed and agility for pursuit, while their forelimbs evolved into grasping appendages, potentially useful for holding struggling prey. Their keen senses were fine-tuned for detecting prey, leading to an effective predator-prey dynamic. Crucially, the early Jurassic also saw the ascendance of the Ornithischian dinosaurs, a group characterized by their distinctive bird-like hip structure and often herbivorous diets. Among these were the first armored dinosaurs, the Thyreophorans. Species like Celodosaurus, a relatively modest quadrupedal herbivore, already possessed rows of bony scutes, foreshadowing the elaborate defensive armaments that would later define iconic creatures like Stegosaurus and Ankylosaurus. These early armored forms indicate an evolutionary arms race already underway, a vital response to the increasing threat posed by evolving theropods. The development of robust defenses alongside increasing body size marked a clear divergence in survival strategies. By the mid-Jurassic, roughly 174 to 163 million years ago, the dinosaurian world had reached a state of breathtaking majesty and complexity. This was an era of unparalleled gigantism. Sauropods, now exemplified by true behemoths like Brachiosaurus, which could stand nearly 13 meters tall and weigh over 50 tons, or the elegant Diplodocus, reaching lengths of 25 meters, truly define the landscape. Imagine vast herds of these colossal herbivores, their thunderous steps shaking the ground, their long necks swaying like biological cranes as they stripped foliage from towering conifers, cycads, and ginkgos. Their remarkably efficient digestive systems, possibly aided by gastroliths, were adept at breaking down tough plant material, allowing maximum nutrient extraction from their prodigious diets. Fossil trackways, sometimes stretching for hundreds of meters, strongly suggest that many sauropod species lived in herds, a social structure offering collective protection and facilitating wide foraging. The apex predators of this mid-Jurassic world were equally impressive. Allosaurus, a truly iconic theropod, emerged as a dominant hunter, reaching lengths of up to 12 meters. This powerful bipedal carnivore possessed a unique skull structure, capable of delivering rapid, powerful bites, tearing flesh from its large prey. Some paleontological interpretations suggest a slash-and-retreat hunting strategy. Fossil evidence from localities like the Cleveland Lloyd Dinosaur Quarry in Utah has yielded numerous Allosaurus skeletons alongside those of sauropods and ornithischians, strongly suggesting they were the primary predators of these colossal herbivores. Other theropods, from smaller, agile hunters to mid-sized specialists, filled out the diverse carnivorous guilds, creating a complex and dynamic food web where every ecological niche was robustly occupied. The ornithischians also continued their diversification. Alongside the impressive Stegosaurus, with its distinctive dorsal plates and a formidable thagomizer tail tipped with spikes, a powerful defensive weapon, other groups like the first true ornithopods were beginning to emerge. These bipedal or facultatively bipedal herbivores, characterized by their grinding dentition and often beak-like mouths, would eventually give rise to some of the most successful dinosaur lineages, including the prolific duck-billed hadrosaurs. Though still in their early evolutionary stages, their presence signaled a future shift in herbivore dominance and a further partitioning of ecological roles. The breakup of Pangea, while a slow process, was increasingly influencing dinosaur evolution. The nascent Atlantic Ocean was widening, and early land bridges were forming and disappearing, leading to increasing provincialism. Different continents began to foster unique dinosaur faunas, setting the stage for the distinct assemblages we see in the fossil record of the later Jurassic and Cretaceous periods. This geographical isolation, combined with continued climatic stability and abundant resources, fueled further speciation and the development of specialized forms. The Jurassic period, particularly its middle stages, represents the zenith of the sauropod-theropod dominance. Dinosaurs had not only survived two major extinction events, but had leveraged their unique physiological and anatomical advantages to construct a global ecosystem of unparalleled scale and diversity. Their reign was not merely one of brute force, but of sophisticated ecological balance, intricate food webs, and a remarkable array of adaptations that allowed them to thrive in virtually every terrestrial environment. From the icy reaches of ancient Antarctica to the arid interior plains of North America, these magnificent creatures walked the earth as its unquestioned rulers. For millions of years, their world seemed immutable, a stable empire of giants that had mastered their environment. But even in a world seemingly perfected, change is the only constant, and the long, slow geological march of time held yet more transformations and challenges in store for the titans of the Mesozoic. The stage was set for their continued evolution and the dramatic unfolding of their story across the vast canvas of the planet. The Jurassic period, particularly its middle stages, indeed presented a seemingly immutable world, a stable empire of giants. But beneath this veneer of enduring majesty, geological forces were relentlessly at work, ensuring that change was not just a possibility, but an inevitability. How did the titans of the Mesozoic adapt to a planet increasingly fractured, its continents drifting further apart, shaping not just new coastlines, but entirely new evolutionary destinies for its inhabitants? The answer lies in a staggering explosion of regional diversification, driven by the very landmass separation that characterized the late Jurassic and into the Cretaceous from approximately 163 to 145 million years ago. The late Jurassic unfolded as a testament to the dinosaurs' adaptability. The supercontinent Pangaea was now irrevocably tearing apart, its fissures deepening into nascent oceans. Laurasia in the north, what would become North America and Eurasia, and Gondwana in the south, South America, Africa, Antarctica, Australia, and India, were distinct landmasses, though temporary land bridges still occasionally linked some regions. This increasing geographical isolation meant that different dinosaur lineages, once widespread, began to evolve in unique directions, leading to distinct faunal provinces across the globe. Nowhere is this late Jurassic splendor more vividly captured than in the Morrison Formation of western North America. This geological treasure trove, unearthed from Colorado to Wyoming, provides an unparalleled window into a vast, semi-arid floodplain ecosystem, punctuated by rivers and seasonal lakes. Here, the sheer scale of herbivorous life reached an astonishing peak. Imagine herds of the truly iconic sauropods, the immensely long-necked Diplodocus, stretching over 25 meters, its whip-like tail a formidable defense. The robust, barrel-chested Apatosaurus, often misidentified as Brontosaurus for many years, a true heavyweight, and its slightly smaller but equally impressive cousin, Brontosaurus itself. Towering above them all was Brachiosaurus, a giraffe-like sauropod with forelimbs longer than its hind limbs, enabling it to reach foliage nearly 13 meters high. These giants were not just diverse in form, but also in their feeding strategies, collectively cropping different levels of vegetation, from ground-level ferns to the very tops of conifer trees. This colossal biomass supported an equally impressive array of predators. Allosaurus reigned supreme, a truly magnificent theropod, reaching up to 12 meters in length. Its powerful jaws, lined with serrated teeth, and strong claws made it the undisputed apex predator of the Morrison ecosystem, hunting both the immense sauropods and smaller herbivores. Evidence from fossil bone beds, displaying clear Allosaurus bite marks on sauropod remains, paints a vivid picture of this ancient predator-prey dynamic. Alongside Allosaurus, smaller but still formidable theropods like Ceratosaurus, with its distinctive nasal horn, and the massive Torvosaurus, added to the predatory complexity, ensuring that no herbivore, no matter its size, was truly safe. Defending against such formidable carnivores required sophisticated strategies. The Ornithischian dinosaurs of the late Jurassic showcased this perfectly. Stegosaurus, instantly recognizable by its double row of large, diamond-shaped plates along its back, and a tail armed with 4 bone-shattering spikes, the Thagomizer was a prime example. These plates, once thought to be for defense, are now believed by many paleontologists to have played a role in thermoregulation or display, while the tail spikes were undeniably for active defense against predators like Allosaurus. Fossilized Stegosaurus plates, and even an Allosaurus vertebra with a puncture wound matching a Thagomizer spike, provide compelling evidence of these dramatic confrontations. These armored herbivores represented an evolutionary arms race, a continuous development of attack and defense mechanisms that refined dinosaur forms over millions of years. Meanwhile, across the emerging oceans, different dinosaur lineages were flourishing. In what is now Tanzania, the Tendaguru Formation reveals a parallel, yet distinct, late Jurassic fauna. Here, the towering Giraffatitan, a close relative of Brachiosaurus, grazed alongside the peculiar spike-armored Kentrosaurus and a diverse array of other sauropods and theropods. This global patchwork of distinct faunas, driven by continental drift, underscores a critical principle of evolution. Isolation fosters speciation and adaptation to local conditions as the late Jurassic gave way to the early Cretaceous, approximately 145 to 100 million years ago. The Earth continued its dramatic transformation. The Atlantic Ocean widened further, separating South America and Africa, and India began its northward journey. Climates became more varied, with some regions experiencing drier conditions, while others became vast, swampy deltas. Crucially, this period witnessed one of the most significant botanical revolutions in Earth's history: the diversification and ascendancy of flowering plants, or angiosperms. While conifers and cycads still dominated many landscapes, the emergence of fast-growing, nutritious flowering plants offered new food sources, leading to a coevolutionary dance with herbivorous dinosaurs. This botanical shift profoundly influenced dinosaur evolution. The early Cretaceous saw a decline in the global dominance of many of the classic Jurassic sauropod lineages, particularly the diplodocids and brachiosaurids. While still present, they were increasingly replaced by new forms, especially the titanosaurs, which would become the dominant large herbivores across Gondwana. These titanosaurs, like Argentinosaurus or Patagodoton from South America, were often even larger than their Jurassic predecessors, pushing the boundaries of gigantism to truly mind-boggling scales. On the predatory front, the early Cretaceous witnessed the rise of new apex predators, especially in the southern continents. In Africa and South America, the Carcharodontosaurids and Spinosaurids began their ascent. Giants like Carcharodontosaurus, a theropod rivaling Tyrannosaurus in size and ferocity, filled the top predator niche in northern Africa. And then there was Spinosaurus, an animal so unique it defied conventional theropod classification, with its immense sail-like fin on its back and crocodile-like snout, indicating a semi-aquatic lifestyle, possibly preying on large fish and other aquatic fauna. These new predators signify a shift in the global balance of power among large carnivores, a further testament to the regionalization of dinosaur evolution. The Ornithischian dinosaurs, too, underwent a spectacular diversification. The armored ankylosaurs, heavily built and covered in osteoderms, some wielding massive tail clubs, became increasingly prevalent, presenting an almost impregnable fortress of bone and muscle against predators. The iguanodonts, large bipedal or facultatively quadrupedal herbivores with distinctive thumb spikes, also thrived, becoming particularly successful in Europe and North America. And most significantly, the early Cretaceous laid the groundwork for the later, spectacular radiation of the hadrosaurs, the duck-billed dinosaurs, which would become the dominant herbivores of the late Cretaceous. These evolving dinosaur faunas, increasingly distinct and specialized across the fragmented continents, speak to a world constantly in flux. From the seemingly stable late Jurassic to the dynamic early Cretaceous, dinosaurs not only adapted to a changing planet but actively shaped its ecosystems, fostering an intricate web of life. Their evolutionary journey, marked by unparalleled diversity and colossal scale, was far from over. Indeed, the mid-Cretaceous would usher in an era where the Earth, now a patchwork of isolated landmasses, would host some of the most bizarre, specialized, and magnificent creatures to ever walk its surface. A final, spectacular blossoming before the ultimate challenge. The stage was set for the final, awe-inspiring act of their reign, as continents continued to drift, climates to shift, and life itself pushed the boundaries of what was possible. The Jurassic period, particularly its middle stages, indeed presented a seemingly immutable world, a stable empire of giants. But beneath this veneer of enduring majesty, geological forces were relentlessly at work, ensuring that change was not just a possibility, but an inevitability. How did the titans of the Mesozoic adapt to a planet increasingly fractured, its continents drifting further apart, shaping not just new coastlines, but entirely new evolutionary destinies for its inhabitants? The answer lies in a staggering explosion of regional diversification, driven by the very landmass separation that characterized the late Jurassic and into the Cretaceous from approximately 163 to 145 million years ago. The late Jurassic unfolded as a testament to the dinosaurs' adaptability. The supercontinent Pangaea was now irrevocably tearing apart, its fissures deepening into nascent oceans. Laurasia in the north, what would become North America and Eurasia, and Gondwana in the south, South America, Africa, Antarctica, Australia, and India, were distinct landmasses, though temporary land bridges still occasionally linked some regions. This increasing geographical isolation meant that different dinosaur lineages, once widespread, began to evolve in unique directions, leading to distinct faunal provinces across the globe. Nowhere is this late Jurassic splendor more vividly captured than in the Morrison Formation of western North America. This geological treasure trove, unearthed from Colorado to Wyoming, provides an unparalleled window into a vast, semi-arid floodplain ecosystem, punctuated by rivers and seasonal lakes. Here, the sheer scale of herbivorous life reached an astonishing peak. Imagine herds of the truly iconic sauropods, the immensely long-necked Diplodocus, stretching over 25 meters, its whip-like tail a formidable defense. The robust, barrel-chested Apatosaurus, often misidentified as Brontosaurus for many years, a true heavyweight, and its slightly smaller but equally impressive cousin, Brontosaurus itself. Towering above them all was Brachiosaurus, a giraffe-like sauropod, with forelimbs longer than its hind limbs, enabling it to reach foliage nearly 13 meters high. These giants were not just diverse in form, but also in their feeding strategies, collectively cropping different levels of vegetation, from ground-level ferns to the very tops of conifer trees. This colossal biomass supported an equally impressive array of predators. Allosaurus reigned supreme, a truly magnificent theropod, reaching up to 12 meters in length. Its powerful jaws, lined with serrated teeth, and strong claws made it the undisputed apex predator of the Morrison ecosystem, hunting both the immense sauropods and smaller herbivores. Evidence from fossil bone beds, displaying clear Allosaurus bite marks on sauropod remains, paints a vivid picture of this ancient predator-prey dynamic. Alongside Allosaurus, smaller but still formidable theropods like Ceratosaurus, with its distinctive nasal horn, and the massive Torvosaurus, added to the predatory complexity, ensuring that no herbivore, no matter its size, was truly safe. Defending against such formidable carnivores required sophisticated strategies. The Ornithischian dinosaurs of the late Jurassic showcased this perfectly. Stegosaurus, instantly recognizable by its double row of large, diamond-shaped plates along its back, and a tail armed with 4 bone-shattering spikes, the Thagomizer was a prime example. These plates, once thought to be for defense, are now believed by many paleontologists to have played a role in thermoregulation or display, while the tail spikes were undeniably for active defense against predators like Allosaurus. Fossilized Stegosaurus plates, and even an Allosaurus vertebra with a puncture wound matching a Thagomizer spike, provide compelling evidence of these dramatic confrontations. These armored herbivores represented an evolutionary arms race, a continuous development of attack and defense mechanisms that refined dinosaur forms over millions of years. Meanwhile, across the emerging oceans, different dinosaur lineages were flourishing. In what is now Tanzania, The Tendaguru Formation reveals a parallel, yet distinct, late Jurassic fauna. Here, the towering Juraphatodon, a close relative of Brachiosaurus, grazed alongside the peculiar spike-armored Kentrosaurus and a diverse array of other sauropods and theropods. This global patchwork of distinct faunas, driven by continental drift, underscores a critical principle of evolution. Isolation fosters speciation and adaptation to local conditions as the late Jurassic gave way to the early Cretaceous. Approximately 145 to 100 million years ago, the Earth continued its dramatic transformation. The Atlantic Ocean widened further, separating South America and Africa, and India began its northward journey. Climates became more varied, with some regions experiencing drier conditions, while others became vast, swampy deltas. Crucially, this period witnessed one of the most significant botanical revolutions in Earth's history: the diversification and ascendancy of flowering plants, or angiosperms. While conifers and cycads still dominated many landscapes, the emergence of fast-growing, nutritious flowering plants offered new food sources, leading to a co-evolutionary dance with herbivorous dinosaurs. This botanical shift profoundly influenced dinosaur evolution. The early Cretaceous saw a decline in the global dominance of many of the classic Jurassic sauropod lineages, particularly the diplodocids and brachiosaurids. While still present, they were increasingly replaced by new forms, especially the titanosaurs, which would become the dominant large herbivores across Gondwana. These titanosaurs, like Argentinosaurus or Patagodon from South America, were often even larger than their Jurassic predecessors, pushing the boundaries of gigantism to truly mind-boggling scales. On the predatory front, the early Cretaceous witnessed the rise of new apex predators, especially in the southern continents. In Africa and South America, the Carcharodontosaurids and Spinosaurids began their ascent. Giants like Carcharodontosaurus, a theropod rivaling Tyrannosaurus in size and ferocity, filled the top predator niche in northern Africa. And then there was Spinosaurus, an animal so unique it defied conventional theropod classification, with its immense sail-like fin on its back and crocodile-like snout, indicating a semi-aquatic lifestyle, possibly preying on large fish and other aquatic fauna. These new predators signify a shift in the global balance of power among large carnivores, a further testament to the regionalization of dinosaur evolution. The Ornithischian dinosaurs, too, underwent a spectacular diversification. The armored ankylosaurs, heavily built and covered in osteoderms, some wielding massive tail clubs, became increasingly prevalent, presenting an almost impregnable fortress of bone and muscle against predators. The iguanodonts, large bipedal or facultatively quadrupedal herbivores with distinctive thumb spikes, also thrived, becoming particularly successful in Europe and North America. And most significantly, the early Cretaceous laid the groundwork for the later, spectacular radiation of the hadrosaurs, the duck-billed dinosaurs, which would become the dominant herbivores of the late Cretaceous. These evolving dinosaur faunas, increasingly distinct and specialized across the fragmented continents, speak to a world constantly in flux. From the seemingly stable late Jurassic to the dynamic early Cretaceous, dinosaurs not only adapted to a changing planet but actively shaped its ecosystems, fostering an intricate web of life. Their evolutionary journey, marked by unparalleled diversity and colossal scale, was far from over. Indeed, the mid-Cretaceous would usher in an era where the Earth, now a patchwork of isolated landmasses, would host some of the most bizarre, specialized, and magnificent creatures to ever walk its surface. A final, spectacular blossoming before the ultimate challenge. The stage was set for their continued evolution, and the dramatic unfolding of their story across the vast canvas of the planet. The Earth, by the mid-Cretaceous, from approximately 100 to 66 million years ago, was no longer the cohesive supercontinent of Pangaea. Instead, it was a mosaic of increasingly isolated landmasses, each drifting further apart, shaping not just new coastlines, but entirely new evolutionary destinies for its inhabitants. This dramatic continental fragmentation, often perceived as a challenge, paradoxically became a crucible for unparalleled biodiversity. As the nascent Atlantic Ocean continued to widen, separating South America from Africa, and India accelerated its northward journey towards Asia, distinct biomass emerged, fostering unique and endemic dinosaur faunas across the globe. This era was defined by heightened provincialism, where evolutionary paths diverged, leading to an astonishing array of specialized forms, each finely tuned to its specific continental stage. This meant that the types of dinosaurs found in North America were increasingly different from those in South America, Africa, or even distinct parts of Asia, creating a complex global tapestry of life. Crucial to understanding this explosion of life was a profound botanical revolution unfolding simultaneously. The diversification and global ascendancy of flowering plants, or angiosperms. Initially appearing in the early Cretaceous, by the mid-Cretaceous, these fast-growing, highly nutritious plants were rapidly spreading, transforming landscapes. Ancient forests dominated by conifers, cycads, and ginkgos began to intersperse with a rich tapestry of flowering shrubs, deciduous trees, and herbaceous ground cover. This shift fundamentally altered the base of the food web, offering new food sources that were easier to digest, faster to grow, and packed with more energy and diverse nutrients. This botanical bounty, in turn, spurred a profound co-evolutionary dance with herbivorous dinosaurs, driving the development of new dental structures, specialized digestive systems, and highly efficient feeding strategies. The world became a far greener, more complex, and ultimately more productive place, capable of sustaining even greater biological productivity, and consequently, supporting an even larger biomass of colossal herbivores and the predators that hunted them. Nowhere was this interplay more evident than in the spectacular radiation of the hadrosaurs, often dubbed the duck-billed dinosaurs. These immensely successful ornithopods, primarily thriving across Laurasia, the northern continents of North America and Eurasia, became the dominant large herbivores of the late Cretaceous. Imagine vast herds, potentially numbering in the thousands, migrating across ancient plains and deltas, their distinctive, broad beaks perfectly adapted for efficiently cropping abundant vegetation. Their most remarkable adaptation was their dental battery, hundreds of tightly packed, continuously replaced teeth, arranged in self-sharpening rows, forming a grinding surface akin to a modern cow's molars, capable of pulverizing even the toughest plant material. Species like Edmontosaurus and the strikingly crested Parasaurolophus exemplify their diversity. Parasaurolophus, with its elaborate, hollow cranial crest, likely utilized it not just for visual display within the herd, but primarily as a sophisticated resonance chamber for low-frequency vocalizations, allowing communication across vast distances in complex social structures and den. See vegetation. Fossil evidence from sites like Egg Mountain in Montana, revealing communal nesting grounds and fossilized juveniles alongside adults, strongly suggests sophisticated parental care, a behavior previously thought rare among large dinosaur groups, hinting at complex social bonds and community living. Sharing these lush North American and Asian landscapes were the ceratopsians, or horned dinosaurs, another lineage that reached its evolutionary zenith in the late Cretaceous. From the iconic three-horned Triceratops, with its massive frill and powerful beak, to the numerous other genera like Chasmosaurus and Styracosaurus, these formidable herbivores developed an astonishing array of cranial ornamentation. Their enormous frills and sharp horns undoubtedly served as potent defensive weapons against the largest predators of their time. However, many paleontologists now believe these elaborate structures also played crucial roles in species recognition, signaling dominance within their herds, and ritualized intraspecific combat for mates or territory, similar to the impressive racks of modern deer or the horns of rhinos. Their sheer abundance and diversity in the fossil record speak volumes about their ecological success, often forming large groups for collective protection and efficient foraging, making them a significant component of the late Cretaceous herbivore biomass. Meanwhile, the armored ankylosaurs continued their evolution into living fortresses. Heavily built, covered from head to tail in osteoderms, bony plates embedded in their skin, and often sporting formidable tail clubs capable of crushing bone, these animals were virtually impregnable against all but the most determined attacks. Euoplosphalus from North America is a classic example, representing the pinnacle of passive defense. Their low-slung bodies, immensely powerful limbs, and broad stance rooted them firmly to the ground, making them exceedingly difficult for predators to overturn. Their presence alongside hadrosaurs and ceratopsians added another layer of complexity to the herbivorous guild, each group specializing in different types of plants and utilizing unique defensive tactics, highlighting a continuous evolutionary arms race against their formidable predators. The burgeoning herbivore diversity naturally fueled the evolution of equally specialized and terrifying carnivores. In North America and Asia, the tyrannosaurids rose to become the undisputed dominant apex predators. Tyrannosaurus rex, appearing relatively late in the Cretaceous period, around 68 million years ago, was arguably the most fearsome land predator of all time. Standing up to 6 meters tall and weighing over 9 tons, its immense skull housed banana-sized, serrated teeth, specifically adapted for crushing bone and tearing flesh, capable of delivering a bite force estimated to be the strongest of any terrestrial animal in Earth's history. This incredible power, combined with its robust bones, powerful leg muscles for surprisingly swift movement, and forward-facing binocular vision, suggests a predator supremely built for large prey subjugation. While debates continue about its primary role as a hunter or opportunistic scavenger, compelling evidence from fossil bone beds, displaying clear T. Rex bite marks on living prey, including a healed Triceratops hip bone with T. Rex tooth gouges, provides undeniable proof of its active predatory prowess beyond the colossal tyrannosaurids. Smaller, yet incredibly dangerous theropods like the dromaeosaurs or raptors continued to diversify. Velociraptor from Mongolia and Deinonychus from North America, though much smaller than their sensationalized cinematic counterparts, were swift, intelligent predators, often depicted as hunting in cooperative packs, using their distinctive sickle-shaped claws and sharp teeth to bring down prey many times their size. Their relatively complex brain structure and keen senses suggest advanced cooperative hunting strategies, making them highly effective and adaptable predators, filling a crucial niche in the diverse carnivorous guilds of the late Cretaceous. Simultaneously, across the fragmented southern continents of Gondwana, a completely different set of apex predators ruled. In Africa, the enormous Carcharodontosaurus, a theropod rivaling T. Rex in size, continued the legacy of the Carcharodontosaurids, specializing in powerful, slashing bites from its blade-like teeth. In South America, its even larger cousin, Giganotosaurus, represented an equally massive and terrifying force, capable of taking down the colossal titanosaurs of that continent. Spinosaurus, with its enigmatic sail and crocodile-like snout, indicating a semi-aquatic lifestyle, also remained a formidable presence in parts of Africa, likely preying on large fish and other aquatic fauna, a testament to unique ecological partitioning in these increasingly isolated landmasses. The continued absence of tyrannosaurids in Gondwana and the distinct predatory forms like carcharodontosaurids and spinosaurids highlights just how profoundly continental drift created separate evolutionary arenas, each fostering its own unique brand of gigantic predator amidst these colossal land dwellers. The skies were still dominated by pterosaurs, although their forms continued to evolve into increasingly specialized niches. While earlier forms like pteranodon, with its impressive wingspan of up to 7 meters, were still soaring over marine environments, new, even larger forms like Quetzalcoatlus emerged, reaching staggering wingspans of 10 to 12 meters. These immense creatures, the largest flying animals ever, likely hunted on land, probing for small prey in a manner akin to modern storks, signifying the remarkable versatility and enduring success of their lineage. Early birds, too, were rapidly diversifying, although still occupying more specialized ecological niches and remaining relatively small compared to their dinosaurian cousins. The mid to late Cretaceous represented the absolute zenith of dinosaur evolution. Across a planet carved into distinct landmasses, life had responded with an explosion of specialized forms, each finely tuned to its unique environment. From the colossal titanosaurian sauropods of South America to the horned and duck-billed marvels of North America and the distinct predatory guilds of Africa and Asia, dinosaurs had achieved an astonishing level of ecological mastery. Their 165 million-year reign, which began in the shadows of a broken world, had culminated in an era of unparalleled diversity, scale, and dominance. They had adapted to every conceivable terrestrial niche, evolving into a multitude of bizarre, beautiful, and terrifying creatures. The world was their oyster, a vibrant, thriving ecosystem, seemingly impregnable, a testament to the enduring power of evolution. For millions of years, this grand, stable empire of giants endured, a pinnacle of life's journey. But unbeknownst to them, a cosmic threat, utterly beyond their comprehension, was already hurtling towards their magnificent world, poised to deliver the ultimate existential challenge to their unshakable reign. The magnificent late Cretaceous world, a vibrant tapestry of specialized life, pulsed with an energy that bespoke millennia of unchallenged dominance. Hadrosaurs grazed in colossal herds, ceratopsians sparred for supremacy, and tyrannosaurids patrolled their territories with an air of unassailable authority. Yet, amidst this flourishing grandeur, a silent, unseen menace was already hurtling through the cold vacuum of space, a rogue object of cosmic indifference destined to intersect with Earth's orbital path. For millions of years, the dinosaurs had weathered geological upheavals, volcanic cataclysms, and fierce evolutionary competition, always emerging stronger. But what defense could an entire planet, however teeming with life, mount against a threat originating from the far reaches of the solar system? The answer, tragically, was none approximately 66 million years ago. In the very last moments of the Mesozoic era, a colossal asteroid, estimated to be between 10 and 15 kilometers in diameter, completed its long journey from the main asteroid belt between Mars and Jupiter. This enormous celestial body, traveling at an unimaginable speed of perhaps 20 kilometers per second, plunged through Earth's atmosphere with a ferocity that would have incinerated any observers in its path. Its descent would have been brief, yet utterly terrifying, a searing, incandescent meteor streaking across the sky, growing larger and brighter with each passing microsecond, culminating in an event of almost incomprehensible violence. The impact site, now famously identified as the Chicxulub crater on the Yucatan Peninsula in what is modern-day Mexico, became ground zero for an extinction event of global proportions, a geological scar almost 180 kilometers in diameter, testimony to the raw power unleashed that fateful day. The sheer energy released upon impact was staggering, estimated to be equivalent to billions of times the force of the atomic bomb detonated at Hiroshima. In that instantaneous moment, rock, water, and life itself were vaporized. The immediate effect was a blinding flash of light, followed by an unprecedented shockwave that ripped through the atmosphere, flattening forests and pulverizing everything in its path for hundreds, even thousands of kilometers around. A plume of superheated material, vaporized rock, dust, and debris erupted upwards, piercing the atmosphere and briefly entering orbit, before raining back down across the entire planet. This re-entry phenomenon transformed the skies into a furnace, generating intense thermal pulses that ignited global firestorms. Forests, prairies, and jungles, already parched from extended droughts, exploded into infernos, engulfing vast swaths of terrestrial ecosystems in a consuming blaze. The heat alone would have been enough to cause widespread devastation, killing countless creatures that had survived the initial shockwave. The impact also triggered colossal megatsunamis. Imagine ocean waves, thousands of feet high, originating from the impact site, surging across the nascent Gulf of Mexico and into the shallow seaways of North America. These monstrous waves scoured coastlines, tearing apart habitats and drowning everything in their path, leaving behind chaotic deposits of mixed marine and terrestrial sediments far inland. Evidence for these tsunamis is preserved in geological layers across Texas, Louisiana, and beyond, a grim record of the ocean's violent response to the cosmic intruder. Simultaneously, the force of the impact sent seismic tremors rippling through the Earth's crust, unleashing earthquakes of unimaginable magnitude and triggering widespread volcanic activity, further destabilizing an already traumatized planet. But the immediate destruction was merely the opening act of a protracted global catastrophe. The vast quantities of dust, soot from the firestorms, and pulverized rock ejected into the atmosphere rapidly formed a dense, impenetrable canopy that blotted out the sun. The world was plunged into an apocalyptic twilight, a perpetual darkness that lasted for months, perhaps even years. Without sunlight, global temperatures plummeted, ushering in an impact winter. Photosynthesis, the very foundation of most terrestrial and marine food webs, ground to a halt. Plants withered and died, leading to a catastrophic collapse of ecosystems from the base upwards. Herbivores, large and small, found their food sources vanishing, and as they starved, so too did the carnivores dependent on them. Furthermore, the asteroid, striking a region rich in sulfur-bearing rocks, released vast quantities of sulfur dioxide into the atmosphere. This gas combined with water vapor to form sulfuric acid aerosols, which then precipitated as devastating acid rain. Oceans, already struggling from surface disruption and plummeting temperatures, became increasingly acidic, particularly at the surface. This acidification decimated marine plankton, mollusks, and other sensitive organisms, creating a ripple effect through marine food chains. Coral reefs, vital nurseries for countless species, were stripped bare. The combined stresses of darkness, cold, starvation, and widespread acidification created an environmental bottleneck from which few large animals could escape. The geological record from the KPG boundary, Cretaceous-Paleogene, formerly Cretaceous-Tertiary, across the globe bears the unmistakable signatures of this cataclysm. A thin, distinctive layer of iridium, an element rare on Earth but abundant in asteroids, provides the ultimate calling card of the extraterrestrial visitor. This layer is often found alongside shocked quartz, microtectites, tiny glass spheres formed from melted rock, and soot, all direct evidence of the immense impact and subsequent global infernos. This geological signature is found in marine and terrestrial sediments worldwide, a testament to the truly global nature of the catastrophe. The dinosaurs, so dominant for 165 million years, were simply not equipped to survive such an abrupt and multifaceted environmental collapse. Their large body sizes, high metabolic demands, and reliance on abundant plant matter or large prey made them particularly vulnerable. The ecosystem they had perfected over eons was dismantled in a geological heartbeat. While some smaller, more adaptable creatures found refuge in burrows, caves, or aquatic environments, capable of surviving on scavenged remains or detritus, the vast majority of life, particularly terrestrial vertebrates weighing over 25 kilograms, simply vanished. The magnificent reign of the non-avian dinosaurs had come to an end, not with a slow decline, but with an instant, violent crescendo that silenced their thunderous footsteps forever. The world, once vibrant and teeming with giants, was now a desolate, dying planet, shrouded in perpetual night, awaiting the slow, arduous process of rebirth. In the wake of such unimaginable devastation, what remained of a world once thrumming with colossal life? The immediate aftermath of the Chicxulub impact was a stark, brutal canvas of desolation. Forests were incinerated, oceans churned with toxic acidity, and a shroud of perpetual darkness suffocated the light. It was a silence unlike any heard for 165 million years, the silence of a planet stripped bare of its giants. Yet, life in its most tenacious forms persisted. Who were these improbable survivors, and what inherent advantages allowed them to cling to existence when so much else perished? The answer lay in size, adaptability, and an ability to seek refuge. Smaller animals, capable of burrowing underground, diving deep into water, or scavenging on detritus, had a critical edge. Mammals previously confined to nocturnal, diminutive existences now thrived. Most were shrew-sized or rat-sized, able to shelter in burrows, feed on seeds, insects, or decaying plant matter. Their warm-bloodedness offered resilience against plummeting global temperatures. Similarly, many amphibians, reptiles like crocodiles and turtles, and freshwater fish found refuge in aquatic environments, insulated from the immediate inferno and preserving some food sources. Insects, with their tough exoskeletons and ability to enter dormancy, also survived, forming a crucial link for recovering vertebrates. Perhaps the most profound continuity of the dinosaur legacy lies not in the fossilized bones of the non-avian giants, but in the fluttering wings of a bird. While the colossal terrestrial dinosaurs vanished, a specific lineage of feathered dinosaurs, the avian dinosaurs, survived the cataclysm. These early birds, often small, agile, and capable of flight, possessed key adaptations. Flight allowed escape from localized destruction, and their smaller sizes meant lower metabolic demands, enabling subsistence on seeds or insects. Rapid reproductive cycles facilitated quicker population recovery. From the fiery crucible of the KPG extinction, birds emerged as the direct, living descendants of the dinosaurs, a testament to their group's enduring evolutionary success and adaptability. Continuing their lineage into the modern era, the world that slowly re-emerged from the impact winter and acid rain was vastly different. The Paleocene epoch, from 66 to 56 million years ago, was a period of arduous recovery and ecological rebuilding. Air cleared, sunlight returned, and temperatures rose. Barren landscapes slowly regreened, initially with hardy ferns and fast-growing angiosperms. With the giants gone, vast ecological niches lay open, ripe for occupation. This ecological vacuum was the single greatest evolutionary opportunity in Earth's history. Since the Permian-Triassic extinction, it was into this reshaped world that mammals, no longer scuttling nocturnal creatures, began their spectacular radiation. Freed from the oppressive shadow of dinosaurs, they underwent explosive diversification, filling every conceivable niche. Within a mere 10 million years, mammals dramatically increased in size and variety. Early Paleocene mammals quickly gave rise to an array of forms: elephant-sized herbivores, formidable predatory creodonts, and early primates. The basic body plans of modern mammalian orders, from ungulates to carnivores, rodents to bats, were established. Their warm-bloodedness, parental care, and diverse dentition proved advantageous in a world demanding rapid adaptation and efficient resource utilization. The stage was set for the Cenozoic era, the age of mammals. A direct consequence of the dinosaurs' demise. The story of the dinosaurs, however, does not merely end with their extinction and the rise of mammals. It continued to captivate for millennia, buried deep within Earth's strata, until humanity began to unearth its truths. For countless generations, humans lived on a planet littered with colossal bones, attributing them to mythical dragons or giants. It wasn't until the early 19th century, with pioneers like William Buckland and Gideon Mantell, that paleontology took shape. The formal recognition of dinosaur, terrible lizard, by Sir Richard Owen in 1842 marked a pivotal moment, an intellectual awakening to a lost world far grander and older than imagined. From those initial discoveries, a scientific revolution blossomed. Paleontologists, geologists, and biologists meticulously pieced together this ancient narrative. Through relentless fieldwork, excavation, and cutting-edge techniques, we reconstructed their lives, how they moved, ate, reproduced, and dominated for an epoch. The study of dinosaurs has become a profound window into deep time, illuminating evolution, adaptation, and extinction on a scale almost beyond human comprehension. Their story teaches us about interconnectedness, the immense power of cosmic forces, and life's incredible resilience. The rise and fall of dinosaurs is not just a tale of ancient giants, it's a profound lesson. It reminds us that dominance, however absolute, is never eternal. It underscores the fragility of even the most successful lineages facing abrupt, catastrophic change. It illustrates how an ecological vacuum can be swiftly filled, reshaping life's trajectory. And most importantly, it highlights life's remarkable persistence, an indomitable force that, even after devastation, adapts, diversifies, and flourishes anew. As we look up at the night sky, catching glimpses of shooting stars, we are reminded of the immense forces that govern our planet. The legacy of the dinosaurs lives on, not only in modern birds or museum skeletons, but in our understanding of life's journey. Their reign, stretching across 165 million years, was a testament to evolution's boundless creativity, a spectacular saga of adaptation, diversification, and ultimate vulnerability. They were Earth's first true empire, and their incredible story is a timeless echo from the deep past, a powerful reminder of the cyclical nature of destruction and rebirth, and the perpetual dance between creation and extinction that defines our dynamic planet. The thunderous footsteps of the giants may have fallen silent, but their colossal shadow continues to inspire wonder, reminding us that we are but a brief chapter in Earth's grand, unfolding narrative. Their story teaches us humility, resilience, and the enduring power of life itself, a legacy etched forever in the annals of time.